afternoon, everyone. I would like to thank you for taking the time to join Test House today for our live webcast. This presentation is in joint collaboration and partnership with both Microsoft and Comparix. Today's topic will be a guide to using MTM within Visual Studio 2013. We will be presenting some of the features of MTM, including creating, executing test cases, looking at exploratory testing, data parameters, and more. I'm proud to be joined today by my colleague, Peter Manring, Visual Studio Test Consultant for Test House. This presentation will last for about 40 minutes plus Q&A at the end. Before I pass you over to my colleague, Peter, please feel free to type your individual questions on our Q&A pod now or during the presentation. We will answer most of the questions if the time permits. A full screen option at the top of your screen is also available, which would be useful when Peter runs his demo. Without further delay, I will now pass you over to my colleague, Peter.
Thank you for that introduction. So we'll move straight on with the presentation. Yes, today's presentation is about MTM, and as I say in this slide, there's quite a few different subjects to cover. We'll be looking at manual testing in general, how to create test plans and test suites, test cases, of course, how to deal with bugs and how to verify those bugs. Also, we'll be looking at some data driving, some automation test cases, and some exploratory testing. So there's a lot of material here, so I'll be keeping a close eye on the time, and then we have some Q&A at the end. So a few words about Test House to begin with. Founded in 2000, we're headquartered in London, that's where we are right now. We have service centres in the UK, Middle East, and in India. We have close partnerships with major software suppliers, HP, IBM, and Microsoft. And we're the quality partner of many large organisations to help them with their testing strategy and execution. We hope to be a global leader in software quality assurance. We always try to push the thinking forwards. We have a wide base of loyal businesses, and we're flexible to deliver the business in any way that our customers is most see fit. We have quite a few businesses that we deal with, as you can see there. It's quite a few big names. Some of the test tools we're experts in, I say Microsoft, IBM, HP. We also have expertise in open source solutions, and we have people who can pick up most tools and use them. And also the applications that we're used to testing on and actually connecting with Visual Studio. So we have a wide experience on many different technologies. So quickly on to then manual testing. Manual testing traditionally has been quite largely manual testing. So you've got black box testing, which is the whole of the life cycle. 70% of testing actually on the manual side, which doesn't require much in the way of scripting or technical skills. It's quite easy to just sit there and drive the application. Additionally, test tools have targeting the scripting side, more technical side. So you need strong coding skills and technical expertise to be able to do that. So Microsoft actually has created MTM to deal with the more manual side of testing, and that's what I'll be demonstrating with you today. There's a bit of a gap in the market there. So MTM is very good for creating and executing your test plans and looking at your test results. I don't have time to go through all of its capabilities today, but I can give you some of the basic ideas. Also, another part of MTM is the lab center, which I can't show you at all, unfortunately, today, but that's to do with managing virtual environments, to do your testing over virtual environments, and it's very useful for that. So we're looking at test planning and test suites then. So the first step with MTM has to work with Team Foundation Server. Okay, you can't just use MTM without Team Foundation Server. So the first thing you have to do is to connect to your server. So that's the first screen. Then once you've done that, that you create a test plan. And there are things inside this test plan which allow you to have align your testing very closely to requirements. So you have some requirements in your system. You can create plans which you know are going to cover those requirements. You know there's going to be tests to cover those requirements. If you use a Scrum-like methodology, which is more and more common these days, then you can do your planning for iterations and make each one plan for different iterations. Tests can be copied between plans, and you can track your testing status and progress very easily because all the information is automatically gathered within Team Foundation Server. So below the test plan, you have different test suites, which we'll demonstrate in due course. And in your test suites, you have test cases, which are the actual sets of instructions which you want your testers to follow when they're doing their tests. Within that, you have the test steps. You can have shared steps, okay? So you can have a set of common steps that are used more than once in your testing area. And then you can data drivers with parameters, which is a very powerful technique. So the test suite, which is one level down from your test plans, they're the containers for your test cases. And you can have them as a hierarchy, although it's best not to make that hierarchy too deep, but you can have them in a tree-like structure, hierarchy. There are three basic types, requirement, query, and static, which we'll cover in more detail a bit later. You can have configurations, which allow you to do your testing under different computer systems, like different operating systems, different browsers. And again, those suites can be copied between the test plans. So the best way to create your test cases or test suites is to do it on requirements. It's very easy to create your test suites based on different requirements. You can base them on queries, so you can gather all of the queries, all of your test cases into one place that fulfill a certain query. And you can also import other test suites from different plans in the organisation, so you can have a common regression set of tests as well. You can assign different users, that's testers in this case. So you can have different testers, different test cases as well, and different configurations can be tested against your individual test cases or your test suites. So, and you have different states that your test suites can be in. They can be in planning, in progress, or completed. So you can stop people from executing the test until you're ready. So your static test suites are just containers that don't rely on queries or anything like that. They're just like miscellaneous containers. You can make query-based test suites, so you can make all your priority 2s appear in one particular place by writing an SQL-like query, and then that will all those test cases will automatically be gathered into one test suite, so you can easily find them. But the most useful and the one I'd recommend you use wherever you can is to have some requirements in the system already. So once you press the requirements button, as seen there, then the test suites will automatically be created, and you'll get linkages as well between any test cases that you create and the requirements as well. So those linkages will be actually put in for you. Configurations that I've mentioned, you can set these up and they allow you to tell your testers to test under different operating systems, different browsers, and then you can have different mixes. And you can apply more than one configuration to a test, and then the system will ensure that test is run for each configuration, so you have a good coverage. So here's a screenshot of creating a test suite. You can see on the left-hand side there, you've got the test plan as the base of that tree structure, and then you've got your test suites underneath, and they are the containers for your test cases. So we'll have a demo now of how to create a test suite, being one of the first steps that you have to do in order to get going with MTM. So I'll just play this video which runs through the screens for you, and I'll talk over the top. So here we have entered MTM, and we have a test plan called Iteration 1. you can see up there on the left-hand side, it's going to be the root of your test plan. That's the name of the test plan. So just by pressing the Add Requirements button, you can see here there's a bit of an SQL query. So that's going to return all the requirement type of objects that's already within MTM of state new. Okay, so you can vary this query and make it as precise as you like. At the moment, it's actually returning bugs as well. You can make this query more specific so it doesn't return bugs. But you can jump straight to the work item just by double-clicking the item in the results pane there, and you can see that there's a link here that's already been made in advance. So you can see there's a test case associated with this bug report. So anybody who looks at this bug report can actually go in there and see what test cases there are against it. That's one of the great strengths of Microsoft Visual Studio and MTM as well. All these things link together and the tools work together. That's a major strength. So returning now to the main screen, you can see here now that we've got an Add Requirements test suite. Okay, and here's the configurations as well. So up here you can see there's a link to requirement 3. So because this test suite was created against requirement 3, you get an automatic link. You just press that and you can come and you can see that requirement associated with that test suite. I haven't got time to run through test requirements in any great detail, but that documentation is there. You can see on the right-hand side here, you've got the in progress state. You can flip that into another state, so you can say, I'm actually in planning. That will prevent anybody executing any tests from this suite until you're ready. So you go ahead and you create some test cases in there, and the linkages would work for you. Now, to create some other test suites, you have to make sure that you highlight the root plan. Otherwise, you build against the requirements, but you want to build against the test plan. So here's a query-based test suite, and this one is saying that I want to see all the test cases with priority 2. Okay. For example, if I can easily change that, I can easily make this query more specific to create different kinds of test cases. If I run that query, I can now see all the test cases in the system already that fulfill that query. And I can choose as many of these as I like, and then the system will automatically gather them together, and you can see them all within this test suite, because they're the ones that actually fulfill that query. So I'll put that one into planning as well, just to show that it's not ready to be tested yet. So you can see that go back to iteration 1, the root of the plan. Go against the new button again, and just this time create what's called a static test suite. It's where you just, if there's no good place for you to put your test cases at the moment, you can just create your test cases in there. It's like a miscellaneous place. It's not ideal to use those. It's probably better if you can put them somewhere where they're more easily found. Okay, we go back to the slides then. So concentrating on the test cases now, which are the actual tests you want your users to perform, or your testers to perform. As you see, they're organised into the test suites. They're just a list of instructions. Do this, and you can you can also put in the results which you expect to see, and then your tests will have to say pass or fail against those individual steps. The steps can be individual or shared. You can data drive as well as parameters, and you can also do automation. Time permitting, we'll do some demonstrations on those later on in this demonstration. So to create a new test case, it's quite simple. You can see you've got a similar looking screen there. So on the left-hand side, you've got the actions you want your people to perform. On the right-hand side, you can have an expected result. Every time that an expected result is defined there, your testers will have to say pass or fail. And that's how the system knows whether the overall part of the test has actually passed or not. So the next demo is just simply creating a test case. So we're going back and we're looking at the state of play as it was just before. So let's say I want to create a test against the add numbers requirement. So I know I need to test that because that's a requirement of the system that's been installed in CFS previously. So I can go and I can look into the system for any test cases that exist already that I know would be good for this requirement. Okay, by building a query. So that's one way to do it, and then you'd see that within that particular test suite. But you'd probably want to create a new one from scratch. So just hit the new button. You have to give your test case a good name. So I'm going to call it new add test. Okay, there's lots of different things you can see here. A test case can be associated with a particular iteration. If you do Scrum, you can assign it to a particular person to do the testing, give it a priority, say whether it's automated or not, and also you can split your project up into different areas, and therefore you can associate a test case with a particular area. But we're not going to dwell on that too much. We don't have much time. So just to concentrate on the actions then, you just highlight the place where you want an action to appear. So the first thing I want my user to do, or my tester to do, is to open the application, right? And on the right-hand side, you say what you expect to happen after that operation has been done. And in this case, it's very simple. Just open the application, simply opens on the screen. Okay. Then on the next line, you write the next operation to be manually executed, and on the right-hand side, what you expect to see as a result of that. You don't have to have an expected result on every step by any means, so you can just have a step to get you to the next part where a test takes place. But every time you see that an expected result is defined, you see a little tick on the left-hand side in the steps. There's also other things you can do here. This is where you control to do your data driving as well. We'll take a look at that a bit later. You can change the order of your steps. You can insert steps at any place. Okay, so I've just done a little bit of mathematics here. See, it's very simple, just for illustration purposes. And then you can also do bold, underline, highlight, just to make things really stand out for your testers, to give things more relevance, more emphasis. You can also attach different things to a test step. You can attach documents to a test step. So when your people are actually executing the steps, they can open a document that might be relevant to that particular step. So you can insert shared steps there as well. We won't be looking at that in too much detail. But if you have a common set of steps, for example, a common piece of navigation, then you can have a library of shared steps and you can import them into any of your test cases that you define. That's where you insert the parameters for your data driving, and that just allows you to replace some of these hard-coded numbers with parameters, and then you can have a data table, so it will loop around the test case and use different data for each time it goes around. That's very useful for doing things like boundary conditions. So if your system acts in a certain way up to a certain boundary and then acts differently beyond that boundary. Data driving is a very good technique to test that with. So here's where you do an attachment. You can attach a file. You can attach a file to an individual test step, or you can attach a file to a whole test case, depending on exactly what you want to achieve. But here I've attached a file to a particular test step. Another good example of these linkages, which are very, very useful. So there's some other tabs to look at. You can have a summary, so you can see exactly what's happening and a history of what's been going on with your test cases. It's always useful to keep those up to date. These are the backlog items. Okay, so a list. If you attach your test case to a requirement, that will be linked. That will be displayed there. You have one for more general links. So if you link it to any other work item within TFS, a list will appear there with different work items. So again, I can go into TFS database and I can link it to any other work item that's in the database. You can attach an external file. So I have a settings file here which I can attach. And associated automation. I don't have time to talk about this very much, as it's a bit more of an advanced subject, but if there's any automation associated, then you can see the details in there. Okay, so that's how to define your test cases. So how do you actually execute your test cases once they've been defined? Well, as I mentioned before, every time that you have an expected result, the system will pause and the tester will have to say pass or fail for that particular line. If a failure is detected, then you can create rich bug reports there and then, and a lot of the information will be filled in for you, as you'll see in a demonstration quite soon. And then when the developers actually have fixed the bugs, then it's very simple to actually check that those bugs have been fixed before that bug is closed, just to make sure that the tester is happy that the problem has been fixed. You can suspend and pause the test as well. The actual piece of software that runs the test is very flexible, so you can run your test in different ways. And any test results that you gather and a history of all the test runs are automatically gathered and put into the TFS database and can easily be viewed with anyone with the correct permissions. So all of your test efforts, all the results, all of the diagnostics that you choose to be gathered when you create and you run your tests are automatically gathered and stored for you in a format that's easily retrievable. So here's a screenshot of someone running a test. You can see you've got the calculator running, which is the application under test, and on the left-hand side you've got the test runner going. Okay, and you can see 3 plus 2, and the expected answer is 5. So in this instance, the tester would mark that as a passed step. So I'll go straight on, and I'm going to talk about how you actually create a bug report. Okay, the bug life cycle is a big part of MTM. It makes communication very easy between the testers and the developers. Instead of trying to shoot emails off to the developers or pass bits of paper around the office, everything is created and stored within MTM and is available for anybody to see at any time. So communication is very, very slick. And everything can be tracked for the managers as well for their reporting. So you can actually create the bugs while you're testing. There's a button on the test runner which allows you to open a bug report, and then you just fill it in and it's stored within TFS ready to be worked on. So there's a demo for that right now. Okay, this is like two demonstrations in one, really. So it's going to demonstrate how to run a test once you've defined it, and also how to do a bug report. Saves a little bit of time. So we've got a few bugs, a few test cases defined that we want to run. So just hit the run button, and you can see on the left-hand side the test runner is there, and the rest of MTM minimizes to give you some space to allow you to actually bring up your application that you want to run. You can dock the test runner on the right-hand side. You can dock it on the left-hand side, or you can float it as well and have it floating around the screen. So if you've got a multi-screen setup, it might be an idea to put your screen that on one screen and your application on another, for example. But I think we'll put it on the left-hand side. And you can also change the size of the screen as well, like so. So you can see that you've got your test steps there. So open application, and there is an expected result. App opens. So the tester will actually go through that and then mark it passed or failed. So you can either just tap the screen there. In fact, I will launch the application, because I'm going to do a bit of a screenshot at the moment. So you can do the 4+3. Let's take it for read that that's actually passed. Remember that this isn't automated, so you have to do this manually. You have to do the steps on the application manually. At this point, I could return to the testing center as well, and it will suspend the test. And then I can just return to the test runner, and it just hit the resume button, and we'll just carry on where we left off. So you can go and do other work in the middle of your testing, no problem. But so I'm going to demonstrate now how to do a bug report. So I said that's failed, so let's just mark that as failed. And straight away I get a chance to create a little comment. So as I say, wrong number, or whatever it is. You can also do screenshots, which are very useful for the developers to see exactly what went wrong. So I can just drop down this button. I can do a rectangular screenshot, like so, to demonstrate exactly what the problem is. And that screenshot then will be included in the bug report for them to look at. So we'll create a bug. You can update an existing bug, but we'll create a bug from scratch. So as you say, it's collecting all of the information it needs, and it's created this bug report for you. And you can see that it's filled in for you exactly what the test steps were. It's been copied from the test case. That screenshot is there. We've also got some diagnostic data at the bottom. You've got an action log and some system information. It tells you which steps passed and failed. If you could look at the system information here, all this information is there for the developer. So there's some technical information there. It shows you what test cases are associated with this bug report, okay, because it was running when the bug was created. Whoever looks after the bugs can create some tasks for someone to actually go and actually fix this bug. And there's some other things as well associated with the bug report. Some usual things like history, links and attachments that I've explained before. Again, you can assign it to a certain person, like a developer, for example, or a development lead. But you have to give it a name, of course. It won't save unless you do give it a name. So you give it something a bit meaningful. Then once you've done that, you can just make sure everything's fine. It's always a good idea to put in acceptance criteria, okay? Just to make clear what it is that should happen for you to accept this bug as being passed. So I didn't do it there, but it's always a good idea to do that. It's very good practice. So I've actually saved that bug. So now that bug is being saved away in GFS. I'll finish the test. Say OK. Up here you can see the overall is a fail because one of the test steps failed. So the overall status is fail. I'll save that, and you can see that it's actually marked that test as failed now, and updated your status bar. So you can see in this test suite how many have passed, how many have failed. And there'll also be quite a detailed record of exactly who did the test, when, and what diagnostics were returned. But let's take a look at it from the other point of view. Now we're looking at it from the developer's point of view. So we'll look at the bugs. Okay, so here are all the bugs in the system. We should see the one we just created. There's the new one, new ag bug num. So we'll just open that bug as a developer and see what it says. And there's the bug we made with all the details. That should help the developer to fix it. So when the developer has fixed it, they should put in exactly what they did. They should keep their bugs up. Everyone should keep their work items up to date with a record of what's happened. Now I'll put it into the done state, which isn't actually correct because done has a very specific meaning within Scrum. It means that everything's finished, but just to move things along, we'll put it into the done status. But the point being that if I go back to MTM and I go to another different part of MTM called Verify Bugs, here's a list of all the bugs on the system. And again, this can be filtered, so I can only look at the bugs that are assigned to me or have been created by me or have been created within a certain time frame. If I refresh the screen just to get the latest information, okay, I can see that at the bottom the bug has been moved. Its status has been updated. So I can take a look at that. So I can take a look at that and see exactly what the developer has done. So I can filter it here against things that have been assigned to me. I can do a custom filter as well. And then if I hit the verify button, okay, that means it will launch the test case that was in action when the bug was created. So I can actually go ahead and verify the bug to see that it's actually been fixed as the developer says that it has. So I've just got to start the test case. Okay, and the same information is displayed to me. I'll just take it as read that the bug has been fixed. So I'll accept all of these tests, okay? Then I will end the test, and you can see that the overall status is now passed. I'll close, and I get this extra screen which says, do you want to actually close the bug down? Or do you want to bounce it back to the developer to say that there's still a problem? So I'll just say, I'll say the comment that the bug has been fixed. And then you save the changes. You can open the bug to take a look if you want to. I'll just save the changes. And that just puts the bug, that tells me that the bug has been verified and no more work needs to be completed on it. So that's how the bug process works. An important part of MTM. So let's take a look at doing some data driving with parameters. Okay, you can replace your constant values with parameters. So in the example we've seen so far with the calculator, we added certain numbers together, but then the test just went through once for those particular numbers. But if you wanted to go through the test several times with different numbers, you would have to write lots of different test cases, which would be very time-consuming. So you can just use the same test case, but use different data. And it will run through the test case using different data. And you can see at the bottom here, you can see the data table building up. So I have a quick demo that shows how that works. Right, so what we have here, again, we're going to take a look at the same scenario, but we're going to look at one of these test cases that we've already created, and I will add some parameters to that test case, which will allow it to be data-driven. Now, it's a little bit restricted in how much data you can actually use because you actually do the data on screen. So the data driving isn't, you can't have huge amounts of data. There are other things you can do to fix that. You can use Visual Studio itself to do some data driving. And then you have a lot more scope. But you can see we've got some hard-coded figures here, like this 10, for example. So let's replace that with a parameter or a variable, maybe, if you like. Call it num1, and insert the parameter there, and if you place the hard-coded value with a variable. So you can do exactly the same here with num2. And of course you need to vary the output, because you varied the input, so you need to vary the output as well. So I just call that answer. Okay. And as you can see at the bottom, it's starting to create a table with those parameters where I can store the data, num1, num2, and answer. So as I put in more parameters, it will build up the data table to allow me to put some data in. So I can put 10 there, for example, 20 there, and of course the answer is 30. I can put in another row. So this time it's 40, 10, and 50. Okay, and I can make a bit more space there, and I can put in several rows of data. Okay, all manual at this time. And as you can probably guess, that num1 and num2 answer parameters will be replaced by that variable data. So line 3, if you think about it, we don't need at all. Okay, so we can actually delete that line now. So that looks good, the way it is at the moment. So we can save and close that. And we'll go to the testing area, okay, where you can actually pick up these test cases and test them. So hit the run button, and we'll see what it looks like. Okay, here's our calculator ready for us. We'll start the test. And so you see, instead of the hard-coded values, you've got num1 and num2. So we'll just say the first line worked okay. And so it plugs in those numbers from the data driving table. So you've got 10 and 20, and the answer should be 30. Okay, so you can do that bit of mathematics on the calculator, and you can say that works, because I'm sure the calculator can handle that bit of mathematics. Then we'll close the app, let's say, and instead of saying end at the end, it says end iteration, move to the next. Because the system recognises that it has to execute this test more than once, because there's more than one row of data. So this time it's changed the inputs to 40 plus 10 is 50. So we'll say yes to that. Okay. And now it recognises that it has ended the application, the test, and it's passed it for us. And it stored all of that information in the database along with all the diagnostics as usual. Okay, so that's parameterization. Okay, so we can do some automation as well. With MTM, I call it semi-automation. It's not like you can record your actions on the screen, but you still have to have your testers actually make sure that something has actually passed or failed. It's what's called an action recording. And there's certain playback facilities you can do. You can play back one step or more than one step at a time, and the system will automatically replay the steps you make, the recording that you made, so you don't have to actually interact with the system. It allows you to verify bugs very quickly, and it's very good for regression testing. The testing that you do again and again and again, every time there's some development, it's a very good idea to do some kind of automation so you can run through those tests very quickly. So basically what happens is you just run the test, turn the recording on. There's a simple button that asks the system to create an action recording. And then you can create a recording and play it back when you like, whenever you run the test. We're running a bit short of time now, so I won't actually demonstrate that, but it's very straightforward to do and quite a useful technique. One last thing I'd like to talk about before I draw to a close, because I think it's a very useful addition to your testing, is something called exploratory testing, whereby instead of just sitting down and writing scripts, you can just let an experienced tester sit down behind the application and just use it as they naturally would, try and find errors, try and find bugs with it as an expert user. And they will find ways of crashing the system that you probably could never think of, being experts in their field. What happens is, in the background, the system will record everything that they do. When they find a bug, they can create a bug report straight away, very similar to the way that you've seen in the previous bug example. And then they can submit that bug report into TFS to be worked on as a normal bug. Another thing the system will do for you with exploratory testing is it will actually create it will make a good attempt at creating a test case based on the steps that were recorded during the exploratory test, so that when the bug is fixed, you have something to verify it against. This has been kind of a criticism of exploratory testing before this sort of technology was available, but now everything can be recorded, so you can actually replay the steps, and you can actually make sure those bugs have been fixed and that problem has been solved. Every time you do a bit of exploratory testing, again, records are kept, so the management can see who did some exploratory testing, how long it took, whether any bugs were found during that exploratory testing session. If any bugs were found, again, you get the diagnostics as well that you choose to collect, and they're stored in the system. So everything that you had before on a normal run, you also get during this exploratory testing session. So you can see it looks slightly different, but the idea is exactly the same. When you get to the exploratory testing bug, it is slightly different in as much as it's possible that you could be sitting there for 10 minutes behind the screen or even longer before you found a bug, and you don't want the bug to contain all of the steps that were done up to that point, because you end up with a very, very big bug report. So what you can do is you have the opportunity to edit the steps that actually are displayed in the bug report, just to show the relevant ones for that particular problem. But apart from that, the bug report is actually the same as you've seen before. And the exploratory testing system will also create a test case for you. You can see on the left-hand side, it's made an attempt to put the actions of what the tester actually did, but it doesn't give the expected results on the right-hand side. So this is some editing that you'll have to do to make this test case usable. In fact, you probably have to expand what the system has written here as well, because since this is automatically generated, it's probably not good enough by itself, but it gives you a very good start. And then this test case is stored for you to be brought out to verify the bug that you found during the exploratory testing. Okay, so let's take a look at what Test House can actually offer for you, because we're starting to run out of time. We can actually do some software installation for you. For MTM or Visual Studio, we can customize it for you. The system's very customizable, okay? And we can also assist with integration to other software packages like SharePoint, for example, or Project Manager. Visual Studio and TFS can work very closely with other software, so you can have different ways of looking at your information. We offer consultancy. There's a scheme called DTDPS, okay, which stands for Developer Tools Deployment Planning Services, And basically what that is if you buy licenses from Microsoft, then you can get free consultancy days, which will allow partners such as ourselves to come into your organisation to give assistance and guidance on how to use these tools to your best advantage, and also maybe to do some training or some other consultancy as well within that package. And now this is free to yourselves, to the clients. It's actually sponsored by Microsoft, so it's well worth finding out whether you have any of these days available, and we can also assist you and with that as well to see how many days you may have. We also do lots of training around anything to do with testing and Visual Studio technologies. We can do training in Coded UI, Test Manager, as in a lot more depth than I've had time to go in today. There's a lot more that the tool can do. Web and load to make sure your websites are reacting quickly enough for your customers. How to use Agile as well, and how to manage teams and how to manage projects within TFS. And also much more advanced automated testing and also lab management if you're an organisation who uses virtual networks to do testing, virtual machines, that kind of thing. Of course, we're on social media as well, so we're on YouTube. If you look for us on YouTube, we've got some demonstration videos for different aspects of what we can do for you. Also Twitter, Pinpoint, you find us on Pinpoint, so you can write about us there. And we're also on LinkedIn, so we're all over the internet, and there's lots of ways you can find us and communicate with us. So that draws my presentation to a close, and now there's a bit of time for some Q&A.
Thank you very much, Peter, for a lovely presentation. We'll go ahead and start with a couple questions that received. The first one being, are there any other ways that MTM works with Visual Studio apart from bug reports?
Yes, well, as you've just seen in the demonstration, one of the best things about Visual Studio and using all the Visual Studio tools together is that you can get all of your team working very closely together and communicating very well. So bug reports is a very good example of that. But also, if you use Visual Studio to do builds, then you can actually make sure that your testers are using the correct build. You can assign a different build to a test plan, so you can display which build they should be using, for example, so they don't start using the wrong build for any particular phase of the project, that kind of thing. And anybody can submit a work item. So anybody who finds a bug can create a bug as well. It doesn't have to be done from MTM. And the latest versions of the software also have things called team rooms as well. It's like a messaging area where anybody who can get into Team Foundation server, be they a tester or a manager or a developer, they can go into these team rooms and they can actually leave messages for each other and let each other know what's going on inside the project. So it really is set up for collaborative working. So there's lots of ways that the whole tool suite allows you to work together.
Okay. Is there another way to perform manual testing if you don't have MTM?
Well, MTM is a very good tool for this. It's designed for it. But there is web access. So I think web access is becoming more and more important within Visual Studio area. And you don't need a very advanced license for it. As long as you've got a basic license to use Visual Studio, anybody can get on and they can use the web access. So all you need is a browser. So you don't have to have anybody have Visual Studio on their PC or MTM. All they need is a browser and the permissions to actually go into the database. And they can do a lot of things on the web access to the browser. They can take a look at the status of the project. They can do a little bit of reporting from there. And there's one area where you can do some manual testing, and it's sort of a cut-down version of MTM. So you can look at the test cases, you can execute test cases with it. You haven't got all the functionality that MTM has got. For instance, you can't define which diagnostics to that you want to collect, or you can't do automation through the browser option. But you can actually execute your test cases, and the results, pass or fail, do flow back into the TFS database. So that's an option for people who haven't got MTM on their machine.
Okay, perfect. We have a set of regression test cases that we run on every sprint. How does MTM allow us to use the same tests in different sprints?
Well, as I said before, sprints or Scrum type methodology is becoming common in software development. And one common way that people use MTM to organise around this is to have a different test plan for every sprint that they do. So obviously you have a different test suites within your different test plans, but MTM makes it quite easy to copy test suites from one plan to another. Okay, so if you have a regression pack within one or more test suites, then you can quite simply copy the test suites that are relevant from one plan to another. There are various ways you can do it. You can do it in such a way that if you update the test cases, then those updates will be reflected throughout the project, or you can copy them in such a way that those updates are not rippled through. So it's up to you how you do it. But it does allow for you to reuse those test cases.
Perfect. And I believe we have time for one last question. Why would you categorize the static test cases as a priority 1? Do you categorize all others as priority 2?
No, the priority system is really down to the way that you choose to use it. I always go by risk. So if for example, there's a section of your application which really must work well because it's critical to the operation of your business or whatever, or even if it's not used very often, but if it is used, then it's very important that it does work properly. For some sort of emergency procedure that has to be done, and if it doesn't work, something very serious will happen. That sort of functionality, I would say, has to have a high priority within your testing scheme. Okay, or maybe it's just a high-profile user who uses these functions, and maybe they need to be high priority. But the whole idea of a static test suite or a requirements one or a query-based one, that's really nothing to do with the priority or the test case that lives inside there. That's just a way to organise the test cases. So the priority should be considered on a case-by-case basis based, I would say, on risk.
Perfect.
Consequences of going wrong.
Perfect. Thank you. Okay, so now that we've come to an end, Peter, thank you again for a great presentation. For everyone listening, the recording will be available early next week at the latest if you want to go ahead and give it a go again. But before we go, if you do have any further questions you would like to ask us, please go ahead and contact Peter at his email that's shown on the screen above. And thank you all very much for joining us, and have a lovely afternoon.